Hello class, welcome to a new video. So uh, in this video we are going to be learning about a new topic, okay, which is called interpolation. Actually, this term interpolation, there are two concepts actually, interpolation and extrapolation. Okay, interpolation and extrapolation. There are these two concepts which we will know side by side, but for your course, for your syllabus, you are only required to learn only about interpolation. Okay, so what do we mean by interpolation? Interpolation is the technique of filling up intermediate terms of a series. Okay, what this means is that suppose you have a series x1, x2 and so on up to xn. Okay, suppose this is your series of values, and suppose a value in suppose what x4 is missing. Suppose the value of the series x4 is missing. Then interpolation is a technique which will be used in order to estimate this missing value x4. Okay, so this interpolation simply means to find, it is simply mean to find or to estimate a missing value. Okay, to find or estimate missing value. Okay, and these values, notice here that this x4, it lies within this series. Okay, it lies between x1 and xn. So if you so interpolation is the technique of finding a missing value which lies within the series. Okay, whereas suppose you have again your series x1, x2 up to xn, and you have you want to find the value which is beyond xn, say xn plus 1, then in order to estimate this you have to use extrapolation. Okay, I hope this is clear. So within the series you have to use interpolation, and outside the series you have to use extrapolation. So in this in your syllabus you are only required to learn about interpolation. That means to estimate a missing value from within a series. Okay, so just like before, you will have two types of variables. You will have a dependent variable, you will have a dependent variable, and you will have independent variable. Okay, so we usually denote dependent variable by y and your independent variable by x, and y is related to x by a function f given by y equal fx. Okay, so y is dependent on whatever value of x takes, and x is independent of any other variable. Okay, so let me explain again. Suppose you have your x values as x0, x1, x2 up to xn, and then your corresponding y values or fx values will be what? Will be fx0, fx1, fx2, and so on till fxn. Okay, then interpolation will be the method of finding the value of fx, okay, for any value within the range x0 to xn. Okay, so interpolation will be the technique of finding fx for finding the value of fx within the range x0 to xn. Okay, so that is interpolation. And extrapolation will be outside the range of x. Okay, it'll be outside this range. Okay, so let us, in order to understand, let us take an example. For example, suppose we are given the production. Suppose we are given the data for the production of tea in Assam. Okay, in Assam for the years for the years 1985, 1990, 1995, then 2000, then 2005. So we are required to find the production of tea, say we are required to find the production of tea for the year 1992. Okay, suppose we want to find the production of tea for the year 1992. Notice here that this year 1992, it lies within this range 1985 to 2005. So that means what technique you have to use here? You have to use the technique of interpolation. Okay, so this can be done using interpolation. Okay, suppose you want to find for the year 2007, then you cannot use interpolation. You have to use what? You have to use extrapolation. Okay, I hope this is clear. I hope this example is clear, okay, about the conceptual difference between interpolation and extrapolation. Now, let us look at what are the assumptions. What are the assumptions of interpolation? What are the assumptions of interpolation? So there are three assumptions of interpolation. The first one is there are no sudden jumps or falls. Okay, so there are no sudden jumps or falls. There are no sudden jumps or falls in the values of the function during the period under consideration. Okay, during the period under consideration. So let us read this again. The first assumption is that there are no sudden jumps or falls. There are no sudden jumps or falls in the values of the function during the period under consideration. So that means, for example, suppose your x values are 5, 7, 9. Okay, and then suppose your corresponding values. Okay, so we'll take maybe 11. Suppose your corresponding values are 0.1, 0.2. Then you cannot have all of a sudden, suppose this value will jump to 75.4 and then it'll come back again to 0.3. So if you have these sort of values, okay, then you cannot use interpolation. Okay, they should not have a sudden jump, sudden rise in the value, or suppose this value, it suddenly becomes very small. Suppose it becomes negative 0.00001. Even this cannot happen. So no sudden jumps or falls should occur in the values of the function fx during this period. Okay, otherwise you cannot use interpolation. The second assumption is that, number B, the rise the rise or fall in the values, the rise or fall in the values should be uniform. Okay, the rise or falls in the values should be uniform. So this means what? We take again that same example I've given just now. Okay, suppose this is your x value 5, 7, 9, 11. Then fx, suppose fx, it will take 0 0.1, 0 0.2, 0 0.3, 0 0.4. So we see here that the rise in the values of fx, they are uniform. Okay, there is a difference of 0.1 in each case. That means from here to here there is a difference of 0.1, from here to here there is a difference of 0.1, and so on. Okay, so this is how it should be in order to be able to apply interpolation. And then the last assumption is that there is a definite and stable relationship y equal fx. Okay, that means this y should have a properly well-defined relationship equal to fx. Okay, it cannot have any sort of other relation with x. It should only be defined by the function f. Okay, so those are the assumptions of interpolation. Now there are two. Now when we come to the methods, of interpolation, there are two methods. Okay, there are two methods. The first method is known as the graphical method or the graphic method, and the second is known as the algebraic. Method. Okay, so what you are required to learn in your syllabus is only the algebraic method. The graphical method is not required for you to learn in the syllabus, but I'll just try to explain a little bit. Suppose you have a graph. Suppose this is your x-axis and then this is your y-axis defined by a function fx. And if you plot the values, suppose you have your values like this, you plot the values x against y. Okay, then suppose you have one value here, then you have one value here, one value like this. Suppose your graph is something like this, and suppose here x equals 0 will be here, x equal 1 will be here, x equal 2 will be here, x equal 3 will be here, x equal 4 will be here. So what you are required to find, suppose, is you want to find the value of y for when x is equal to 2.5. Okay, 2.5 will be located here between 2 and 3. Okay, so what you do by graphical method is you try to plot this graph, and then you try to locate the point x equal 2.5. You try to locate the point in the graph. Okay, so an estimate of y for when x equal 2.5 will be here. Okay, so this is just one simple example of graphical method, but you are not required to learn this method. I am just showing you so that you'll just have some knowledge regarding this graphical method. So now we will come to the main portion of your syllabus, which is the algebraic method. of interpolation. So algebraic method of interpolation, there are three very popular formulas, okay, that you will be learning. Okay, the first formula is known as the Newton's Newton-Gregory's forward interpolation formula. Newton-Gregory's forward interpolation formula, or it is simply known as forward interpolation. And then the second one is Newton-Gregory's backward interpolation formula. Backward interpolation. And the third one is known as Lagrange's formula, Lagrange's interpolation formula. So these are the three interpolation formulas that you will be learning. Okay? These are the three interpolation formulas that you will be learning. So I'll just give you a brief idea about each of one of them. The first one, Newton's forward interpolation formula, it is used when the missing value lies towards the beginning of the series. Okay, it lies towards the beginning of the series. Okay, then it lies, let me try to explain. Suppose you have your series x0, x1 and so on till xn. Then if your missing value lies in this area, in this beginning part of the series, okay, then you use forward interpolation. Then you use forward interpolation. But if your missing value lies towards the end of the series, okay, the ending of the series, then you use backward interpolation. Okay, and one more thing, in order to be able to use forward interpolation, or backward interpolation, you have to remember that the difference between, you have to remember that the interval of differencing should be same. I hope you remember what is this interval. What is this interval of differencing? Okay, I hope you remember what is this interval of differencing. We denote this by h. Okay, and in order to use forward or backward interpolation formula, this interval of differencing should be equivalent. That means it should be same for all the intervals. Equivalent or same for all the intervals. So what does this mean? Equivalent interval of differencing. It means that the difference x1 minus x0 should be equal to the difference x2 minus x1, should be equal to the difference x3 minus x2, and so on. Okay, so this h should have the same values. Okay, then only can you apply forward or backward interpolation. Okay, that is the another condition that is that you are required to have if you want to apply forward or backward interpolation. Okay, so I hope you remember. I'll just repeat this again. Forward interpolation is used when what? The missing value is in the beginning of the series. Okay, and then backward interpolation is used when the missing value is towards the ending of the series, and in both cases h is equidistant. Interval of differencing is equidistant, which means that this is equal to x1 minus x0 equal to x2 minus x1 and so on. Now let us go to the third formula, which is known as Lagrange's interpolation formula. Interpolation formula. So Lagrange's interpolation formula is used when your interval of differencing h is not equidistant. Okay, whenever you have the case of a non-equidistant interval, then you use Lagrange's interpolation formula. And it does not matter whether your missing value is towards the beginning or it's towards the ending of the series. If your interval of differencing is not equidistant, then you use Lagrange's formula. You cannot use You cannot use forward or backward. Okay, that means when that means when x1 minus x0 is not equal to, say, x2 minus x1, not equal to x3 minus x2 and so on, that means interval of differencing h is not equidistant. Okay, and in this case you have to use Lagrange's formula. You have to use Lagrange's formula. Okay, I hope this is clear. So now let us go to those formulas one by one. You have your dependent variable y, you have your function y equal fx. Okay, and you have your independent variable x, and this independent variable x takes values x0, x1, x2 till xn, and corresponding y values takes values y0, y1, y2, yn. So, and you know that y0 is simply fx0, y1 is simply fx1, and so on. Okay, so if you have this set of values where the interval of differencing is equidistant, that means h is equal to x0 minus x1 equal to x2 minus x1 and so on, then your Newton's forward interpolation formula is given by y equal to fx y equal to fx equal to y0 plus delta plus u into delta y0, and then plus u into u minus 1 by 2 factorial delta square y0 plus u into u minus 1 into u minus 2 divided by 3 factorial delta cube y0 and so on, plus your last term will be u minus 1, u minus 2 and so on, u minus n minus 1, okay, divided by n factorial into delta n y0. Okay, so this formula, you already know what is delta. So this formula here, this u is what? Where u is equal to x minus x0 divided by h. Okay, and x is the period of interpolation, x0 is the first argument, and then h is the interval of differencing. Okay, I hope this is clear. Remember this formula, it may look difficult, but then you just have to remember, and when we will be doing some calculations, you'll understand that this is very easy actually. You just have to remember the formula. So let me explain again. This u is what? This u is x minus x naught by h, where x is your period, x is your period of interpolation, x naught is your first argument, and then your h is your interval of differencing. Okay, period of interpolation means what? It means it will be given, it is that period in which the value is missing. Suppose you want to find the missing value for x equal 2.5, then your period of interpolation will be 2.5. First argument is the first value of x. Remember, x takes the values x0, x1, and so on. That means x0 is this first value, and interval of differencing is h. Okay, so hence this is the formula of Newton's forward interpolation. Remember that in the formula we are using y0 everywhere, y0, and y0 is the first y value. Remember, I've shown you that table x and y, x0, x1 up to xn, y0, y1 up to yn. So notice here in the forward interpolation formula, we are using this first argument x0, and we are using this first value of y, which is y0. Okay, so this is the Newton's forward interpolation formula. So the next we go to Newton's backward interpolation formula. Okay, we go to the Newton's backward interpolation formula, and it is given as follows. So again, you have your x and y values just the same like before. Then the formula is given by this: y is equal to fx, it is equal to yn. Remember here we are not using y0 anymore, we are using yn, which is the last value of your series, yn plus u delta yn minus 1, n minus 1, then plus u into u plus 1 by 2 factorial into delta square yn minus 2, and then plus u into u plus 1 u plus 2 divided by 3 factorial into delta cube yn minus 3, and then so on, u into u plus 1 u plus 2, and so on, u plus n minus 1 divided by n factorial into delta n y0. Okay, so this is the backward interpolation formula, and notice here that instead of y0 we are using we are using yn minus 1. It keeps on reducing, yn minus 1, yn minus 2, yn minus 3, and finally y0. And then notice here that instead of u minus 1 we are taking plus 1. So instead of minus we are taking the plus sign everywhere, u plus 1, u plus 2, and so on. And here your u also will be different. U is equal to x minus xn divided by the interval of differencing. So it's almost same like forward interpolation, except here instead of x0 you are using xn, which is the last value of x known as the last argument. Okay, this x and h, they are the same thing, period of interpolation, and h is your interval of differencing. Okay, so this is your Newton's backward interpolation formula, and you can only use backward and forward only when the interval of differencing is equidistant. Next, let us go to the last formula, which is known as Lagrange's interpolation. Lagrange's interpolation formula. Okay, Lagrange's interpolation formula. So this formula is given as follows. All the variables, they mean the same thing, so I'm just giving you the formula. So the formula is given by y equal fx equal to, this first term will be x minus x1 into x minus x2, so on till x minus xn. And here you have to subtract x naught from everything. I mean, you have to subtract everything from x naught. X naught minus x1, x naught minus x2, and so on, x naught minus xn. Okay, and here into y naught. So remember, the first term is relating to y naught, so you have to, in the denominator you have x naught everywhere. The second term you have to multiply with y1, so x1 will be removed. Okay, so notice here that for y1, here you will have x minus x naught first, then x1 will not be there, you will have directly x minus x2, x minus x3, so on till x minus xn. And then in the denominator you will have to minus x1 everywhere, x1 minus x naught, x1 minus x2, and so on, x1 minus xn. Okay, so this will go on in the same way for y2, y3. Okay, so you can understand. Then the last term you'll have to multiply with yn. So that means here xn will be removed. So here x minus x1, I mean x minus x naught, x minus x1, and so on, x minus xn minus 1. And then in the denominator you have to minus xn everywhere. Xn minus x naught, xn minus x1, and so on, xn minus xn minus 1. Okay, so this is Lagrange's interpolation formula. So this formula is very simple. So here you can see that the formula does not involve any interval of differencing. Okay, so you can easily find for any point in the series, you can easily estimate using Lagrange's interpolation formula. Okay, so we have learned about these three formulas, and I would like you to practice these formulas, or all three formulas. Okay, you practice the formulas: Newton's forward, Newton's backward, and Lagrange's formula. Okay, before I send the next video, please be able to write by heart, to write from memory all these three formulas. Okay, if you practice, they are not hard at all, they're very easy. And the questions which will be asked from these topics in exams, you only need to remember these formulas and you can easily apply them. Okay, for now, as your homework, you please remember and by heart all these three formulas, and then from in the next video I will solve some numerical examples using these formulas.